Hello everyone, welcome to Tutorials Diary. This is lesson 3 of Ethereum Development course for beginner. If you haven't gone through my last two sessions, I would recommend you to go through that session before you jump to this third session, because in the very first session we have covered how to set up your development environment for Ethereum, and in second session we have discussed about building a smart contract in Solidity language in the Remix IDE. So this is the third session, and in this session we'll show you how you can compile your smart contracts and how you can deploy that on in the inbuilt blockchain, which is known as JavaScript virtual machine, and then how you can test that smart contract functionality, and then how you can debug that smart contracts. So let's go and start with this session. So if you remember, in the last session we have shown you this smart contract, which is student.sol, and we have developed this and we have added two functions here. One function to set the student details, second is to get the student detail. Now to compile this code, you have to go to the very first option, which is compile, and click on this start to compile. Whenever you click on this one, if this shows a green symbol, then there is no issue or no warning. So suppose I remove this public sign from here, then it will, and I will save this one, cancel, and then start to compile again. This will show me a warning that I haven't defined the visibility of this function. So this is one of the warning which I will see here when I will remove the public from this function. So I will add it again. So let me add that again. So this is how you can compile your piece of code very easily without any changes. Let me do it here. Again, it become green. Now if you have any syntax error, suppose I will remove this from here. If you try to compile again, this will show you the error message. This error message shows that okay, the syntax is not correct. So let's fix that one. So this is very simple, again very straightforward, no rocket science here again. So very simple, you can just go and compile and see what warnings and what issues you have. Okay, so you also have the option to auto compile. Auto compile means that as soon as you are developing the code, it will compile the code at the same time. So this is up to you, you want to use this option or not. And further, you have the option of details. You can go to this detail tab, and that will give you the further detail about the smart contract. We will not go into this detail, but out of this detail we will use one section in the last session of this course, which is known as the ABI, which define about the interface of this smart contract, which we'll discuss in the last session. But here, if you want to read this information, you can go to detail and check all the detail which will come there. Now this is about compilation. Now the next step is that once you compile, once you see okay, there is no issue or warning in your smart contract, you are good to go to next step. The next step is that you have to start deploying on the smart contract on a blockchain. Now there are different kind of blockchain available in the right now for Ethereum. Ethereum has one main blockchain which is known as mainnet, and there are other test blockchain as well, and you can also set up the blockchain on your local environment, your own blockchains. But to start with, what we'll do, we will use the inbuilt blockchain which we have with the Remix IDE, which is known as JavaScript virtual machine. So in the next session, we will show you how you can use this Remix IDE to connect to Ganesha blockchain, and then in the fifth session we'll show you how you can use the MetaMask to connect to your test blockchain. So, but before we go to that lessons, we have to understand that how you can deploy it to inbuilt blockchain in the Remix IDE. So for that one, we'll go to this run option. As you can see, there are three options here. JavaScript virtual machine is your inbuilt virtual blockchain which we have in this one, and then here second option is injected Web3 option which is used to connect to your test Ethereum blockchain, and third is Web3 provider. This is used to connect to your Ganesha blockchain or any other custom blockchain. So our focus in this session will be on JavaScript virtual machine. So we select that one. As soon as you select that one, you will get some default account. So this is around 5 account which will get. All the account will have 100 Ether associated. Okay. Now, to deploy this smart contract on a blockchain, first of all, you need to have an account, which will get by default the 5 accounts. Okay. So in case you are building your own blockchain for Ethereum, the very first thing you do, you have to create the accounts there, because without having an account, you will not be able to deploy your smart contract on the blockchain. So you can use any account from this list to deploy this smart contract on the JavaScript virtual machine. So I will take the first account, just say deploy. Now you can see it got deployed on the blockchain, and this got deployed on some address. Okay, so this is one thing which you have to always remember. Whenever you deploy any smart contract on a blockchain using the account, that will get deployed on some address. The address will be assigned to that smart contract on the blockchain. So you will always refer that smart contract by that address only. And one thing important to understand here, if you deploy the same smart contract 2 times, so then it will be residing on the blockchain 2 times on different addresses. First time it is on address 1, second time on address 2. So let's suppose you have developed a smart contract. First of all, you have deployed on a blockchain. Then you have made few changes to the smart contract, and then you have deployed again. Now you will have both the smart contract running on the same blockchain on different addresses. So that means you can still access the old smart contract as well and the new as well, because they are on separate addresses. Now let's see, whenever you deploy the smart contract on the blockchain, this will show creation of student is pending. That means whenever you are deploying something on a blockchain, you need to spend some Ether from your side. So since we are using the inbuilt blockchain, so we need to worry about the Ethers, because this is all fake Ethers. But whenever you work with mainnet Ethereum blockchain, you have to use the actual Ether. You have to use actual money to deploy something on the Ethereum blockchain, because the miner will come who will mine your transaction, and once he confirm, then that miner will get some fees. So this is how Ethereum works. So whenever you deploy smart contract, this is pending, and if you open this one, this will show transaction got mined. So someone mined this transaction and it got successful. Okay, so this is very fast on your local blockchain, but when you go to Ethereum mainnet blockchain, this may take some time. Okay, this will not be so quick as you see on your local blockchain, because it is mining all the things which you are running right now. Okay, and as you can see down here, you have to spend gas whenever you deploy something on a blockchain. So there is cost associated with each transactions. This is not free of cost. Okay, so this is how you can go and deploy to your inbuilt blockchain through Remix. Now the next step is that how we can test. Let me take only one smart contract. Now you can test in the same IDE only. Now what I will do, I will pass 2 parameters to the set function, my name and age, transact. So whenever you say transact, if you go down here, this will, again, what you are doing, you are changing the state on a blockchain. You are assigning some value to 2 variable which is currently on a blockchain. That means you are making some modification in a smart contract which is currently running on a blockchain. So whenever you're making some changes to a state on a blockchain, again, you have to pay some ether for that one. You have to pay the gas for that one. So someone will mine that your transaction and then it will be successful. So same thing will happen for this one also. If you expand this one, so this one is transaction got mined, as you can see in the screen. So this is showing transaction got mined and this is successful. And you have paid some, there is cost associated with this transaction as well. Okay, so as you can see down below, this is the input which we have sent, Vikas and 32. Now you can call this get function. Whenever you click on this get function, this will show you the detail, whatever we have set in the set function. Now, if you have noticed one thing here, whenever you call this get function, if you expand that one, here there is no mining required, because let me expand that one, because here you are not changing any state, you are just viewing the information only, because the function which we have set here is public view. You are not changing any state on a blockchain. Okay, so whenever you are not changing any state on a blockchain, you need not to pay any cost for that one. You can get the information easily. Okay, so now the last concept which you have to understand in this session, how to debug your piece of code. So you have this option to debug. You can click on this one. Once you click on this one, this will open this debugger. Here you can start this debugger. Here you can stop this debugging. And as you can see, there are options here: step over, forward, and this will go over some of the steps one by one. If you click on this debug option, start this one. This will start debugging. Okay, one by one. So this is how you can debug, but generally this is not required for beginners because you can easily track all the things from here itself. But I'm just trying to make sure that you're aware that we have this functionality available in this Remix browser, which you can use from your side. So this is all we have in this session. I'm hopeful that this is helpful for you to get the understanding about how you can compile and deploy your smart contract. Thanks for watching.